Hello, my name is Addison Abbott, and the topic I will be presenting on today are why are newborns rarely born with cancer, and what does this tell us about the causes of cancer in general? We're going to explore the biological reasons behind cancer's rarity in infancy, and what does this tell us about why and how cancer develops later in life. I think this is a very interesting topic purely because we truly cannot go about finding the cure for cancer if we don't understand the cause of it. And the lack of cancer in infants really reveals to us the causes of cancer in general and how we can go about treating it. But before we can jump right in to discuss the correlation between newborns and cancer, we need to understand and discuss cancer itself and really get a biological overview of the nature of cancer. According to National Cancer Institute, cancer is a disease in which some of the body's cells grow uncontrollably and spread to other parts of the body. In the pictures here, we can see some visible examples of cancer on a microscope slide. So the one to the far left, closest to our text on top, is going to be skin cancer, and then to the right of that, also on the top, is leukemia, and below that is breast cancer. So each of this shows cancer on more of a microscopic level. So as we said before, cancer is a disease where cells just grow uncontrollably, and it can start anywhere and disrupts the function of nearby organs. Normally, cells divide only when needed, and old and damaged cells are removed through a process called apoptosis, which is programmed cell death. This system is tightly regulated by the cell cycle, which has built-in safety checks to prevent cancerous cells, like this one, for example, from proceeding and protruding too far. When the system breaks down, abnormal cells keep dividing. They avoid this programmed cell death and may forms these tumors, some of which are benign, which are non-cancerous, but others are malignant, which is where we actually get cancer itself and are capable of spreading. When it does spread, this is called metastasis, and it's where they travel throughout the body and form new tumors, and this is when cancer is often life-threatening. We're going to go into a little bit more detail on the cell cycle and more specifically the checkpoints within the cell cycle, because this is so important to cancerous growth and spread, because obviously we are familiar, the most elementary definition of cancer that we talked about before, and it's when the cells grow uncontrollably or divide and reproduce uncontrollably. And the reason why as in a healthy body, we don't have cancer cells or these rapid growths is due to these checkpoints that get rid of these damaged cells. So during the cell cycle, our body has several internal checkpoints that are going to regulate this. They make sure that the DNA is intact and that conditions are safe before the cell actually divides. For example, the G1 checkpoint is going to check for DNA damage specifically before DNA is copied, so it can catch that issue before it continues. The G2 checkpoint ensures all DNA is correctly copied before the cell divides. So this really highlights the importance of DNA within this, because we have two solid checkpoints during DNA replication. And then finally, the M spindle checkpoint ensures chromosomes are properly attached and aligned during division. So each of these checkpoints are going to either inhibit or encourage cell growth and division, and it is really important to the stopping of cancer or in the growth of cancer. Like, for example, we can see in this photo right here that these cells our cancer cells are beginning to protrude from the normal cells, and we can also just see the difference in appearance from the normal cells to the cancerous cells. Even if this is a very textbook definition and photo, we can still see the general nature of the different look of the cells. So now we need to discuss the main topic. Why aren't newborns born with cancer? Newborns are not born with cancer because for four main particular reasons. Of course, there's many, but these are the four ones we're going to focus on. Newborns have not had time to accumulate mutations. Cancer usually develops over many years due to these mutations, and newborns have simply not been alive long enough for this buildup to occur. So one of the main causes of cancer are these bad mutations, I guess you could say. And so if newborns have not had time to develop that, they're obviously not going to be born with it. They also have highly efficient DNA repair and apoptosis systems. In fetal development, cells are really good at fixing DNA or self-destructing if something's wrong, and it protects the body from this abnormal growth. So, of course, our cells also have these checkpoints, but in someone who has cancer, it's going to obviously, like we discussed, going to miss that step. But newborns are born with highly efficient DNA repair and these cell death systems in order to prevent cancer itself. Newborns also possess robust cell cycle checkpoints during development, which is kind of what we just discussed. In general, they're just born with more of an ability to fight off cancer and fight off these bad cells from reproducing. Newborns have also not yet been exposed to carcinogens. So this carcinogen is what we're going to discuss a little bit in this next slide as well. But not being exposed to the main hazards of cancer is really going to make a contributing factor. So to go into a little more detail about carcinogens, these are going to be substances or exposures that increase the risk of cancer by damaging DNA or disrupting normal cell regulation. And some obvious examples are going to be chemical exposure, which is going to include things like smoke or industrial solvents. We have certain like physical agents, which are going to be like UV radiation, which comes from the sun. We also have our biological agents, which are going to be like HPV or hepatitis B viruses that can be inherited or just happen over time. Some other lifestyle factors as well is going to impact this, like diet, tobacco use, and alcohol. So tobaccos have not been exposed to these carcinogens, and if they have, even if they have been, it's not been over too long of a period of time that they can really accumulate and cause these mutations that are going to cause cancer, fortunately. Now to answer the question that we're all waiting for, so what does this tell us about the nature of cancer? So what exactly does this reveal to us? We can determine from the fact of newborns not frequently having cancer that it's not based purely on genetics, which has been a very common belief. A lot of the times when we see someone completely healthy diagnosed with cancer, someone younger, like in their 30s, we wonder if it's purely a genetic factor, but the fact that newborns are born with it reveals that there's more to the story. This is going to be a progressive disease that's driven by time, environment, and cellular damage a lot more than just genetics. And it also is going to reinforce the idea that aging, chronic inflammation, and impaired immune surveillance are going to be key factors within cancer development. The natural defenses like cancer, such as apoptosis and checkpoints that we discussed before, are very strong early in life. And finally, this is also going to tell us that most cancers are acquired and not purely inherited. So it's so much greater. There's so much more to the story than just a genetic disease. So, like in conclusion, the rarity of cancer at birth reveals just how well God designed our bodies to prevent this from happening. Cancer only occurs when the multiple protective layers that are in place have begun to fail. We're born with everything functioning properly most of the time, and from there, that's when cancer can develop over time as these systems begin to break down. So a really interesting application to this is, how does this apply to cancer treatment? After all, before we can cure any disease or really find a solution, we have to fully understand the problem at hand. And because of what infants reveal to us about cancer in general, we really have some ways that we can go about cancer treatment or have possible ways to begin finding a cure. And of course, there are so many different ways and there's so many things people are trying, but these are some ways that we can begin to look at curing cancer. Like for example, restoring cell cycle checkpoints. Since cancer cells often bypass these, some treatments aim to restore them and stop tumor growth. Of course, like we talked about, the infants have really well organized, well structured, and well functioning cell cycle checkpoints already. So if we can further address this and keep cancerous cells from dividing and catching the errors in mutation, it would prevent the spread of cancer. We can also target DNA target DNA repair mechanisms. In healthy newborn cells, repair is very efficient. Some therapies now target weak DNA repair systems in cancer cells and kill them more selectively. This is kind of the same thought, is because infants, we know, cells function so efficiently in catching these possibly dangerous cells. If we can kind of take that same aspect into adulthood and just cancer later in life, we do have a possible treatment there. And then finally, kind of the same thought, is reactivating apoptosis. Newborn cells self-destruct if they're damaged, and that's what our cells should do as well. But of course, that's where cancer is dangerous. That does not occur. So cancer therapies tries to force cancer cells which have disabled apoptosis to die. So of course, when we have this programmed cell death, that can allow for cancer to stop. So, in conclusion, the rarity of cancer in newborns teaches us that our bodies are really naturally built to fight cancer, but over time, mutations, exposure to carcinogens, and breakdown of repair systems allow cancer to develop. Even though God has designed our bodies so intricately, and at birth we are born with the ability to fight off these cancers, over time, just gradual wear and tear, and of course exposure to just the elements of this world cause cancer, unfortunately, to develop in some people. By studying why cancer is so rare at birth, though, we really gain important insight on how to better prevent, detect, and treat cancer all across the lifetime, and in so many different people and in so many different cases. Thank y'all so much.